From the gentlest breeze to the fiercest hurricane, weather shapes our world. It's a constant dance of elements, a symphony of pressure, wind, and temperature that paints the sky with an ever-changing canvas of chaos and calm. Atmospheric pressure, the weight of this air pressing down on us, plays a critical role. Differences in pressure create wind, as air rushes from high-pressure areas to low-pressure zones, striving for equilibrium. Temperature, fueled by the sun's energy, adds another layer of complexity, influencing air density and the formation of clouds. High above us, powerful rivers of wind, like the jet stream, snake their way across the globe, steering weather systems along their path. Understanding these fundamental forces unlocks the secrets behind the awe-inspiring and sometimes destructive power of weather. Few natural phenomena rival the raw power and spectacle of a lightning strike. In an instant, millions of volts of electricity discharge from the sky, illuminating the world with a brilliant flash and a deafening roar. As warm, moist air rises and collides with colder air aloft, a turbulent battle ensues. Ice crystals within the cloud collide, creating static electricity. This separation of charges sets the stage for a dramatic release of energy. A pathway of ionized air forms, connecting the heavens and earth, and in a flash, a surge of electrons races down this path, producing the brilliant flash we call lightning. The rapid heating and expansion of the air creates a shock wave, the thunder that follows, its echoes reverberating through the sky. Imagine a column of wind, a swirling vortex of unimaginable power descending from the sky, its funnel a dark and ominous specter against the storm-tossed clouds. This is the terrifying reality of a tornado, nature's most violent windstorm. Tornadoes are born from a unique and volatile combination of atmospheric conditions, often within the chaotic environment of a supercell thunderstorm. As warm, humid air collides with cooler, drier air, a horizontal spinning effect can develop. This spinning tube of air, caught within the updrafts and downdrafts of the thunderstorm, can be tilted vertically, transforming into a rotating column of wind. As the tornado descends, air is drawn inwards, its rotation intensifying, creating a vortex of incredible speed and destructive power. Understanding the conditions that lead to their formation and heeding the warnings of meteorologists are crucial steps in mitigating the risks posed by these formidable storms. From gentle showers to torrential downpours, rain is a familiar sight. But what happens when the rain turns solid, transforming into icy missiles that bombard the earth from above? This is the intriguing phenomenon of a hailstorm. Hailstones are born within the turbulent updrafts of thunderstorms, high above the freezing level. As tiny water droplets are swept upwards into the frigid upper reaches of the storm cloud, they freeze on contact with ice nuclei. These nascent hailstones are then caught in a turbulent dance within the storm cloud, tossed up and down by powerful updrafts and downdrafts. With each upward journey, the hailstones collide with supercooled water droplets, which freeze upon impact, adding another layer of ice to their growing mass. Eventually, the weight of the hailstones overcomes the updrafts, and they plummet to earth, sometimes with destructive force. Ball lightning, a puzzle of plasma and light. Throughout history, there have been reports of a rare and elusive phenomenon, a celestial enigma that has captivated the imaginations of scientists and skywatchers alike. Ball lightning. Unlike the fleeting brilliance of a typical lightning bolt, ball lightning is said to appear as a glowing sphere, hovering or drifting through the air for seconds, even minutes, before vanishing as quickly and mysteriously as it arrived. Eyewitness accounts describe ball lightning in various ways: a luminous orb, a fiery sphere, a pulsating glow. Some reports claim it moves erratically, bouncing off objects, while others describe it as hovering silently in midair. Numerous theories have been proposed to explain ball lightning, each attempting to unravel the puzzle of its formation and behavior. Despite the lack of a definitive explanation, the allure of ball lightning persists, reminding us that our understanding of the natural world is still incomplete. Hurricanes. When the ocean rises in fury. Over warm ocean waters, a storm gathers strength, its winds whipping the sea into a frenzy, its clouds spiraling inwards towards a central point of ominous calm. Hurricanes are born from humble beginnings, often starting as clusters of thunderstorms over tropical or subtropical waters. As warm, moist air rises and condenses, it releases heat, fueling the storm's growth. The Earth's rotation imparts a spin to the developing storm, causing it to rotate, drawing in even more warm, moist air. As the storm intensifies, it goes through a series of well-defined stages, from a tropical depression to a tropical storm, and finally, when its sustained wind speeds exceed 74 miles per hour, it earns the formidable title of hurricane. Understanding the science behind hurricane formation, tracking their movements, and improving early warning systems are essential for mitigating the risks posed by these powerful storms. Northern Lights, a celestial ballet of light. Imagine gazing up at the night sky as it erupts in a mesmerizing display of color and light. Shimmering curtains of green, blue, and red dance across the heavens, painting the darkness with an ethereal glow. This is the Aurora Borealis, also known as the Northern Lights, a celestial ballet orchestrated by the Sun and Earth's magnetic field. When charged particles from the Sun collide with Earth's magnetic field, they are guided towards the poles, where they interact with atoms in the upper atmosphere. As the solar wind particles collide with oxygen and nitrogen atoms, they transfer energy, exciting these atoms to higher energy levels. When these excited atoms return to their normal state, they release the excess energy in the form of light, creating the dazzling auroral displays that illuminate the polar skies. Climate change. Tipping the scales of weather. Our planet's climate is a complex and interconnected system, a delicate balance of forces that has sustained life for millennia. But this balance is being disrupted, altered by human activities that are releasing massive amounts of greenhouse gases into the atmosphere. These gases, acting like a blanket around the Earth, trap heat and are causing our planet to warm at an alarming rate. This warming trend, known as climate change, is not just about rising temperatures. It's about disrupting the very systems that govern our weather patterns, leading to a cascade of effects that are already being felt around the globe. As the planet warms, the atmosphere can hold more moisture, leading to more intense rainfall and an increased risk of flooding. Climate change is also altering wind patterns, intensifying storms, and shifting the tracks of hurricanes, making them more unpredictable and potentially more destructive. The future of weather prediction, harnessing the power of data. From ancient civilizations looking to the skies for signs to modern meteorologists relying on sophisticated technology, humans have always sought to understand and predict the whims of the weather. Today, we stand at the cusp of a new era in weather forecasting, an era driven by big data, artificial intelligence, and a deeper understanding of the complex forces that shape our atmosphere. Modern weather forecasting is a marriage of science and technology. Sophisticated computer models, fed by a constant stream of data from satellites, weather balloons, radar stations, and ground-based sensors, provide us with increasingly accurate forecasts, allowing us to anticipate and prepare for severe weather events. Artificial intelligence and machine learning are playing an increasingly important role in weather prediction, helping us to analyze vast amounts of data, identify patterns, and improve the accuracy of forecasts. These advances will be crucial in helping us to mitigate the impacts of severe weather, protect lives and property, and adapt to the challenges of a changing climate. Human adaptation, weathering the storm. Throughout history, humans have faced the challenges of a changing and often unpredictable climate. Today, our capacity for adaptation and resilience is being tested like never before. From building seawalls to protect coastal communities to developing drought-resistant crops, humans are finding innovative ways to adapt. We are investing in early warning systems and strengthening infrastructure, developing new technologies to mitigate impacts. Adaptation is also about changing behaviors and making sustainable choices, working together to create a resilient future. A tapestry of wonder. From the lightning's flash to the whisper of the wind, weather is the grand orchestra of our planet, a symphony of forces that sustains life as we know it. It's a constant reminder of the intricate dance between energy, atmosphere, and water that shapes our world. As we've journeyed through the science behind these weather wonders, from the fury of hurricanes to the ethereal glow of the northern lights, I encourage you to keep exploring, keep questioning, keep marveling at the world around us. delve deeper into the science, understand the impact of our changing climate, and become a steward of this precious planet we call home. For in the end, weather, in all its grandeur and ferocity, reminds us of the interconnectedness of all things, a delicate balance of nature's forces that deserves our respect, our awe, and our unwavering commitment to its preservation.